Welcome to today's short demo on C-PHY from Introspect technology. Today we'll be demonstrating the SV3C C-PHY test system, and we'll be describing basic pattern generation capability as well as pattern capture capability within the C-PHY paradigm. So the C-PHY generator and analyzer systems are described here. The generator is called the SV3C CPTX, and it's a compact system that's capable of producing C-PHY compliant patterns across 4 lanes simultaneously. So each lane is 3 wires, and so this is 4 times 12 wires within this compact test system. The system includes built-in encoding and mapping inside the hardware for pattern generation, and it also includes analog controls for receiver testing, such as per wire skew injection and per wire jitter injection, as well as per wire levels control, whether these are differential voltage controls or common mode voltage controls. And the system is able to produce stressed eyes, basically for receiver testing, as well as any frame video data, so packets that contain complete video pixels in them. The analyzer is shown on the bottom side here. It's called the SV3C CPRX, and it's a capture tool as well as an error detector. So this is a tool that enables users to perform BER testing on C-PHY signaling. And what we describe at the bottom left corner here is what Introspect technology defines as multi-target BER testing for C-PHY. And what this really means is that not only is the tester able to perform error counting and error detection on the data words that are decoded already in hardware, but it's also able to perform error detection on the wire states, the symbols, and even the individual wires themselves, which are essentially non-deterministic in C-PHY, but the system is able to lock onto them and perform BER testing on them. One of the ways it's able to perform that, of course, is it has a built-in C-PHY CDR in hardware, and it also has the built-in MIPI C-PHY termination control for adapting between LP signaling and HS triggering. So the hardware setup for today's demo is illustrated here. It's basically the C-PHY generator is the top SV3C system in this image, and then the C-PHY analyzer is the bottom one here. The generator is able to produce 4 lanes of 4 trios, basically, as I mentioned earlier. So there are 12 wires coming out of this high-density, high-speed connector and going into the cable assembly and into the receiver. So 12 wires on the receiver, 12 wires on the generator make up 4 lanes of C-PHY. What the generator also has is extra resource called a replica channel generator, and that's the extra wire that we show here going all the way to the oscilloscope. So whatever the generator is doing to the receiver, whether it's the Introspect receiver itself or any piece of silicon, we have an extra resource where we could view the actual functional pattern that's being produced on an external instrument like an oscilloscope. And everything is controlled with the ESP software that's shown on the left-hand side here. So we'll go ahead and start the demo now. So we'll show the desktop first. What I have here on this desktop is basically a live connection to the oscilloscope with the view of the replica channel on it. And I have an Introspect ESP instance for the generator, as well as an Introspect ESP instance for the analyzer on the right-hand side here. So we'll start with the generator first. To generate a pattern using the Introspect ESP system, your user only needs to enter one command in the test procedure, and that's called MIPI C-PHY generator1.setup. And the parameters for this command, of course, are listed on the top section of the tab as I show here. And so what we're describing here is basically we want to produce data on all 4 trios simultaneously, and we want to produce the data at 2.5 gigasymbols per second. And then the pattern itself, what we've selected to do today is basically a packet loop that's infinitely repeating, and that contains PRBS9 data inside the payload. This is one of the early physical layer test patterns that is being considered right now, and so that's pre-built into the tool. The tool contains built-in HS-only patterns as well as built-in LP patterns, as well as packet loops that transition between LP and HS. And as always with Introspect ESP, the user is able to create custom patterns and custom packet loops as well. So if I go ahead and just start this pattern right now, and we'll look at the scope is starting from a stop state, the LP111 state, and we click run. And so now what it's done is basically it's generated a pattern. The pattern is going into the receiver, but I'm viewing the replica channel here, wire A on the replica channel. And so if we just zoom out on the scope, we'll see basically the packets repeating forever. Even though the test procedure has ended, but the packets are repeating forever because that's what we instructed the tool to do. So essentially that's our packet generator. It's now producing the patterns. We can go ahead and look at the capture tool and try to learn what the pattern is and understand what's coming into the tool. So to actually capture C-PHY patterns using Introspect ESP, the user needs only 2 lines of code, as I show here. The first line is a global clock config.setup line, which has parameters listed above, and it's really needed just to say that we want to measure at 2.5 gigasamples per second. The second line is a data capture 1.run line. So we'll look at the data capture 1 component here, and we just want to specify how we want to perform the measurement. So what we've set up here is basically to say that we want to capture on all 4 lanes, 1, 2, 3, 4. We actually do not want to declare any expected pattern. If we were performing a BER test, then we would have declared an expected pattern. For now, we just want to learn whatever pattern is being received, so we don't have to declare anything. And the mode that we want to capture in is basically HS triggered, which means that we want to trigger on one LP to HS transition, capture the packet, and then stop. We don't want to capture anything else. We just want to capture one packet. There are certainly other capture modes that are included as well. So this is the entire procedure required to learn the pattern that's being generated by the generator right now. So I'll click run on it. And so it takes me to the log window. And we go into the results tab. And if I click on the result, I get the viewer for the capture tool in C-PHY. And so for those familiar with C-PHY, the waveform on the top is the wire waveform. So we're starting after the LP transition, we're starting in the 333 pre-begin or preamble signaling. And so the wire AB is just transitioning through this pattern that's repeating for a while. Wire BC pair is doing the same, and then wire CA pair is doing the same. So for the expert eye, we'll see the proper transitions on the wires. And as mentioned in the introduction of this demo, the tester is able to decode the wire information into symbols, to wire states first and then symbols, of course, and so that's what we're seeing here. We're not seeing any data yet because the tester recognizes that we're in the preamble and it's not ready to decode data. But if we keep scrolling, we now see the sync word as highlighted here by the tester. And then once the sync word is received, the tester is now decoding the integer data as well. And so these are the first few words basically out of the PRBS pattern that's produced. And so we can scroll on and see the PRBS data. And of course, as we mentioned, this was performed on all 4 lanes simultaneously. So the capture tool is able to receive the wire information, decode it into words, into symbols. I can click Alt arrow here and go to the post section of the data. I can scroll back to the sync section very quickly. And then on top of that, of course, the capture tool gave us a sense for how long the preamble was, how long the post was, between the HS and LP transitions. So there you have it. This is a very basic introduction to the pattern generation and pattern detection tools out of the Introspect SV3C C-PHY test systems. Thank you.